So in this video, we will go over the 2017 AMC 10B problem 16, and it's about a problem involving casework and counting with digits. So the problem says, how many of the base 10 numerals for the positive integers less than or equal to 2017 contain the digit 0? If you don't know what bases are, don't worry, it's just ignore this, it just means numbers. So a lot of people may take an approach to this problem where they split the cases into the numbers having 1 0, 2 zeros, and so on, and then adding them all up. But in this video, we won't take that approach because it's quite complicated. Because, for example, if you're looking at the number of numbers with 2 zeros, then the locations of the 2 zeros would vary. So you would have to split it into subcases as well, and that would make things a bit more complicated. So in this video, the approach we're going to take is we're going to count the number of numbers without a 0, and then subtract it from 2017, the total number of numbers, to get the number of numbers that have at least 1 0. And that would make things a bit easier because counting the number of numbers without a 0 would involve it wouldn't involve more than one subcase. So that'll be good. So we're going to take that approach. So what we're going to do is wait a sec. I will just okay. Yeah, there's some technical issues. Okay. So we're just looking for 2017 minus the number of numbers without a 0. Okay, so we're gonna split the cases into, let's see, okay, I'll just put this in blue. 1-digit numbers, 2-digit numbers, 3-digit numbers, and 4-digit numbers, because we're only going up to 2017, so up to 4-digit numbers only. So for 1-digit numbers, well, that's pretty straightforward because only 1, 2, 3, all the way up to 9, those are the only 1-digit numbers that don't have a 0. So the answer to this would just be 9. And then for 2-digit numbers, we have 2 digits. So the first digit can be any digit except for 0. So 9 possibilities for this. And for the second digit too, we can have every single digit except for 0. So 9 again. So then 9 times 9 would just give us 81. Okay, it's 9 equals 9. I'll just write it down like this. And for 3-digit numbers, I don't need that actually. So for 3-digit numbers, same logic. There are 9, so we can have every single digit except for 0 for the first digit, so 9. And then for the second digit, the same logic, every single digit except for 0, and the same for the third digit. So you can see that it's much easier to calculate the number of numbers without a 0, because you can just, there's only one case you have to look at one subcase you have to look at for each case. So it'll just be 9 times 9 times 9 equals 729. And then for 4-digit numbers, well, we only have to go up to 2017. So let's first just look at, we have to look at some subcases for this, but it doesn't make a difference. Let's just say we're going to look at numbers from here to here that don't have a 0. So basically all the 4-digit numbers that start with a 1. So we already have, we're going to set this. I'm going to put that in a different color to show that it's already set. So we're going to set this as 1. And then now we're going to look at the possibilities for each of these digits. And that'll just be 999 again, like this one, because we're just looking for 3 digits that don't have a 0. And we already have the answer to that here. So yeah, so this part, it will just be the same as this. And we can realize that the answer to this will be the same as this as well, because we have the first digit fixed, and then we're just looking for 3 digits. We're just looking for a 3-digit number to go in here that don't have a 0. Yeah, so 729 for this case too. And the reason why I only looked at the case where it starts with 1 is because we can observe that from 2000 to 2017, there is always a 0. There is always a 0 in the second digit. So all of these numbers contain a 0, so we don't have to count it. We're not gonna count this in here because it has a 0. We're counting the number of numbers without a 0. So yeah, so that means we're done with calculating this. And that means we can just calculate this now. So the answer would just be 2017 minus 9 minus 81 minus 729 minus 729. Oops, that's 7. And that will just give us 469. That is neat. Yeah, and we can see that this is here in the answer choices. Yeah. So, yeah, the main thing to take away from this video is that when you can see multiple ways to approach a counting problem. Like for example, we kind of went in we were looking for the complementary value and then subtracting it from the total value, because the complementary value was easier to calculate. So yeah, always look for the easiest way to calculate things, because even if one type of strategy it seems possible, it can end up very complex, and you may make some calculation mistakes easily in the middle. So what I want to tell you guys about casework with digits is that the best way to count for these kind of problems will be to divide the cases into the number of digits of the numbers, because that would make things a bit easier to observe, like this problem. So yeah, hope you enjoyed this video, and hope to see you in more of my videos.